So in the previous lessons, we learned various ways in finding the derivative of a function. Now in today's video, we are going to do something quite different. We are going to look at the basics of integration and how to find the integral of a given function. So let's start off with this. Let's assume that we have a function f of x, which is equal to x cubed plus 4. Now let's try to differentiate this function. So we have the derivative of f of x with respect to x equals, we have d dx of x cubed plus 4. Now if we differentiate this function, then we are going to obtain 3x squared. Now 4 is a constant, so it goes to 0. So if you differentiate this function, then you have 3x squared. So what then is integration? Integration is basically the reverse process of differentiation. So what this primarily means is that if you should integrate this function, then you are supposed to arrive at the original equation f of x. So let's try to integrate this function. So we are going to have the integral of 3x squared dx. Now if you want to integrate this function, basically you are going to increase the exponent on x by 1, and then you divide through by the exponent or the total exponent on x. So that becomes 3x exponent 2 plus 1 divided by 2 plus 1, and that is equal to, you have 3x cubed divided by 3. 3 cancels out 3, and then you are left with x cubed. Now looking at these two expressions, you realize that they are too different from each other. Here we have x cubed plus 4, and then here we have x cubed. Initially, we said that if we should integrate this function, then it was expected for us to get the original function back. However, we got something quite different from this. We have x cubed instead of x cubed plus 4. So how do we explain this? Now you need to understand that whenever you differentiate a function which contains a constant term, the constant is lost during the process of differentiation. So especially if you don't know the past history of the differentiated function, it will be very difficult for you to know the value or the size of the constant. So in this case, the best thing to do is whenever you integrate a function, it is expected that you add a constant term c to the final expression. Now the value of c here does not give the exact value of the constant in the previous function. However, it only gives an indication that there might have been a constant in the differentiated function which you don't know its value. So whenever you integrate a function, it is wise that you add a constant c to the final expression. Now we call 3x squared the integrand. Now let's consider a list of some basic integrals and how we can apply them in solving certain questions. So let's start off with, let's say you have the integral of a constant function. So k here is a constant. Now if you want to integrate a constant function, then basically what you are going to do is you want to integrate k with respect to x, and so you multiply k by x and then you add a constant value, say c. So for example, if you want to integrate the constant 4 with respect to x, then that is equal to, you have 4x plus c. Again, if you want to integrate the function e dx, then we have e to be a constant, so that's going to be e times x plus c. So basically this is how to integrate a constant function. Now let's move on to the second one. So let's say you want to integrate a function of the form a times x to the power n with respect to x. So basically, you are going to maintain a, and then you increase the power on x by 1. So that becomes n plus 1. And then you divide through by the total exponent on x. So that becomes divided by n plus 1 plus c. Notice that a and n are all constants, and n can be any value. Say n can be 0, n can be a fraction, it can also be a positive or negative integer, except that n should not be equal to -1. So for example, let's say you want to integrate the function 3 times x exponent 4 dx. So basically we are going to increase the exponent on x by 1. So that's going to be 3x exponent 4 plus 1 divided by 4 plus 1 plus c. So that becomes 3 times x exponent 5 divided by 5 plus c. So still under this rule, let's try some more examples. So let's say we want to find the integral of the function 2 over x cubed with respect to x. So we can rewrite this as 2 times x to the power -3 dx. So we are going to increase the exponent by 1 and then divide through by the total exponent. So that's going to be 2x to the power -3 plus 1 divided by -3 plus 1 plus c. So that is equal to, we have 2x exponent -2 divided by, this becomes -2 and then plus c. So 2 cancels out 2, we are left with -x exponent -2 plus c, and then we can simplify this as -1 over x squared plus c. Now let's move on to another example. Let's say we want to find the integral of the function square root of x with respect to x. So we can as well express this as x exponent 1 over 2 dx, and this will be equal to, we have x to the power 1 over 2 plus 1 divided by 1 over 2 plus 1 and then plus c. So we have x to the power 3 over 2 divided by 1 over 2 plus 1 also becomes 3 over 2 plus c. So you multiply the numerator by the reciprocal of the denominator, so that we have 2 over 3 times, now x power 3 over 2 becomes the square root of x cubed. So the 2 which is at the denominator gives an indication that it is a square root, and then 3 here means that you have x to the power cube and then plus c. Now let's move on to, let's say, type 3 or root 3. So we have the integral of 1 over x dx to be equal to ln of the absolute value of x plus c. So example, let's say you have the integral of 5 over x dx. You can pull out 5 so that you have 5 times the integral of 1 over x dx, and then that is going to be 5 times, now when you integrate 1 over x, you have ln absolute value of x, and then you multiply that by 5 so that you have 5 times ln of the absolute value of x plus c. 4. Let's say you want to integrate the function 1 over ax plus b. Now this is equal to, you have 1 over a times ln of the absolute value of a times x plus b plus c, where the value of a is not equal to 0. So let's say if you want to find the integral of a function like 2 over 4x plus 1 dx, then first of all let's pull out 2. So we have 2 outside times the integral of 1 over 4x plus 1 dx. Then this is equal to, we have 2 times, this is going to be 1 over, now we have our a to be 4 and then b to be 1, so that's going to be 1 over 4 times ln of the absolute value of 4x plus 1 and then plus c. So we multiply 2 across, so we have 2 goes here once, 2 goes here 2 times, so that becomes 1 over 2 times ln of the absolute value of 4x plus 1 and then plus c. Now let's move on to 5. So for 5, let's say we want to find the integral of the function ln of x dx. Now this is equal to x times ln of x minus x plus c. So how do we obtain this result? Now we are going to verify this by using what we call integration by part, and that is given by the formula u div equals u times v minus the integral of v times du. So considering this function, that is ln of x, we are going to say that we have u to be ln of x, and then we have the v to be 1 times dx, so 1 times dx. So first of all, let's find du dx. So we have du dx to be equal to, when you differentiate ln of x, you have 1 over x, and we are going to have du to be equal to 1 over x times dx. Again, here we have dv to be equal to 1 times dx, which is the same as dx. So we can say that dv dx is equal to 1. Now if you want to find v, that means you want to integrate this so that v will be equal to, when you integrate 1 with respect to x, then you have x. So now using this formula, let's try to find the integral of this function using integration by part. So we have the integral of ln of x dx to be equal to u. Now we have u to be ln of x times v. V is x, so we have this times x minus the integral of v. We have v to be x, and then du is 1 over x times dx. So this becomes, we have x times ln of x minus x cancels out x, and so we are left with the integral of 1 dx. So we have x ln of x minus, now when you integrate 1, which is a constant, with respect to x, then you have x, and then you add the constant value c. Therefore when you integrate ln of x with respect to x, then you have x ln of x minus x plus c. So let's try this. Let's say we want to integrate the function ln of 5x squared dx using integration by parts. So with this, we can say that, or we have u to be equal to ln of 5x squared, and then we say that du dx should be equal to, now to differentiate this, we are going to differentiate what we have in the bracket, and that's going to be 10x. So that becomes the numerator divided by what we still have in the bracket. So that is 5x squared. So x cancels one of the x here. 5 goes here 2 times, 5 goes here once. So we are left with 2 over x. So that is du dx. And again, we have divin to be equal to 1 dx. And so we are going to have vin to be equal to x. Now let's substitute this into this formula. So using the formula, we have u times vin minus the integral of vin du. So basically, we have u to be ln of 5x squared. So that becomes ln of 5x squared times vin. Now vin was equal to x. So vin equals x minus the integral of vin, which is x, times du. Now we have du dx to be 2 over x. Therefore, du will be equal to 2 over x times dx. That is very simple. So we have 2 over x times dx. Now let's simplify. So we have x times ln of 5x squared minus x cancels out x. So we are left with the integral of 2 dx. Now don't forget that ln is a natural log, and so we can expand this as we are going to have ln of 5 plus ln of x squared. And even with that, according to the properties of logarithms, we can transport 2 to be in front of the natural log. So that becomes plus 2 ln of x minus, now when you integrate 2, you have 2x, and then with the constant. So we have the integral of ln of 5x squared dx to be equal to x into brackets ln of 5 plus 2 times ln of x minus 2x plus c. Now let's move on to 6. So let's say we want to find the integral of the function e to the power x dx. Now this is nothing but e to the power x plus c. That is very simple. And let's say you want to find the integral of the function e to the power kx dx, then that is equal to, you have e to the power kx divided by, you differentiate the exponent, and then you have k. So divided by k plus c. Now a typical example is if you want to integrate the function 2 over 3 times e to the power 5x dx. So you can pull out the constant, which is 2 over 3. You can pull out the constant. You have e to the power 5x dx. So you have 2 over 3 times, this becomes e to the power 5x. You differentiate 5x, you have 5, and then plus c. So this becomes 2 times e to the power 5x divided by 3 times 5, 15, plus c. Now let's continue. Seven. Let's say you want to integrate the function a to the power x dx. So that is equal to, very simple, you have a to the power x divided by ln of a plus c. So giving the integral of the function 2 exponent x dx, that is simply 2 exponent x divided by ln of 2 plus c. Now at this point, we are going to consider some problems regarding polynomials. So let's say you are given the polynomial 4 plus 3 over 7x minus 6x squared, and then you want to integrate this polynomial. Now you can decide to express this polynomial into its individual terms and then integrate term by term. So that is to say that you can express this as the integral of 4 dx plus integral of 3 over 7x dx minus the integral of 6x squared dx. Or better still, you can do it straightforward. So let's try to do it straightforward. So you are going to integrate 4 so that you have 4x plus you integrate 3 over 7x, so that's going to be 3 over 7, and then you have x exponent 2 divided by 2 minus 6x cubed divided by 3 plus c. So let's simplify this. So we are going to have 4x plus 3x squared over, now 7 times 2 is 14, and then you have minus 3 goes here once, 3 goes here 2 times, so you have 2x cubed plus c. So this is the integral of this polynomial. 9. Let's also try this. Let's try to integrate the function 2x cubed minus 3x divided by 4x. Now you realize that the denominator affects the two terms we have at the numerator. So we can simplify this, or we can better still expand this as 2x to the power 3 divided by 4x minus 3x divided by 4x or dx. So let's simplify this. X cancels out one of the x's here. 2 goes here once, 2 goes here 2 times. So we have x squared divided by 2. We have x squared divided by 2 minus x cancels out x, so we have 3 over 4 dx. Now we are going to integrate term by term. So we have x to the power 3 divided by 2 times 3 minus 3 over 4 x plus c. So this becomes x to the power 3 divided by 6 minus 3 over 4x plus c. Now let's try the last one for today's lesson. We want to integrate the function 1 minus x all square dx. Now there are so many ways in solving such a question. However, because this is basically an introductory video, we are basically going to use a method that is familiar to all. So let's try to expand this expression. So expanding this, we are going to have 1 minus x times 1 minus x, and you expand this, you have 1 times 1 is 1, negative x times 1 is negative x, 1 times negative x is negative x, and then negative x times negative x is plus x squared. So that becomes 1 minus 2x plus x squared. So we are going to have the integral of the function 1 minus 2x plus x squared dx. So we integrate term by term. We are going to have x minus 2x squared divided by 2 plus x cubed divided by 3 plus c. So let's simplify. We are going to have, let's say we have x cubed over 3, and then 2 cancels out 2. We are left with negative x squared plus x plus c.